Hey everybody, this is Alex Merced from alexmerced-patternmatcher.com, and what I want to do is introduce to you a new library that I wrote for JavaScript. Soon, there's going to be a new video series that I'm going to be putting out, 100 Days of Go and Rust, where I've been spending 100 days, where I will be doing 100 videos on different topics within Go and Rust. So like, generally in each video I will show something in Go, then Rust. One of the things I really like in Rust, and that's coming to Python in 3.10, which is releasing in October 2021, is a feature called structural pattern matching. Okay, structural pattern matching is a feature very similar to switch statements, but a little bit different. And it's generally, typically, you'll see this in like functional languages like OCaml, Haskell, whatnot. Just to kind of show you a quick example of a switch statement. Okay. So we'll just say index.js. So usually, like, the way a switch statement works is we'll have a value, so const value equals 5, and then we put it through a switch. And we'll say switch value, and then we'll make a bunch of different cases. So we'll say, hey, in the case where the value is 1, then I want you to do this. Okay, and we'll just say, you know, console.log cheese. And if the case is, let's say, 5, we'll say console.log bread. And then, you know, after basically what it's doing, it's going to match up this to see if this equals this. But that's the extent of it. So basically, it only runs the case if this equals this. Okay, and then you put, generally you're supposed to put a break statement after each one to kind of make sure that you don't end up having multiple cases run. So you do break, 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 and then you generally put a default case at the bottom that's like, you know, console.log no match. Okay, and that would do that. So let's just like run this in terminal. Node node index.js, and that works. But what if you want to do something more complex? You could do a bunch of if statements and say, okay, if this is true, this is true, but that gets really tedious, writing lots and lots and lots of if statements. That's kind of the reason you do switch, because the idea is you're trying to match up one value across a bunch of things. So what if I wanted to like not only match the value, but I also want to like check its type or check how many things are in the array, or something like that? That gets a little bit more complicated, okay? Because again, it only matches the value. So typically, if you wanted to do something kind of like pattern matching with a switch statement, what you would do is you would just say switch is true, and then the cases might be a function that returns true or false. So that way, and then generally like only one of those functions are going to return true, and that way you can kind of create, but that's still like not, I don't think it's like super intuitive or clear when you're reading the code, because you're not sure what the value is that's being matched. Okay, because structural pattern matching and like, again, Python, Rust, whatnot, allows you to do much more complex matching. It's not just saying, does this value equal this value? You can be like, okay, does it have like 3 items? Does it, literally anything you want to express, and then if it matches that pattern, great. And then you can trigger some actions, whether you return a value, whatnot. So what I did is I created a library called Pattern Matcher. Okay, so first we need to create a npm project, npm init-y. Okay, so now we have and now we're going to install the package, npm install, and it's alexmerced-patternmatcher. Okay, so see, alexmerced-patternmatcher. That's the library to install. Okay, now how do we use it? You need to declare some variables. So you say const, and then we're going to just say equals require alexmerced-patternmatcher. Okay, and the main function is create matcher. There's create single matcher. There's match object and match array, and I think that is all the functions that this library comes with. Okay, so the way it works is that you're going to create a matching function. and the function's already going to, because the reason is you might want to use the same set of possible cases in many situations. So instead of redefining the function over and again and then running the function, you can just create the function once, use it multiple times to match the same pattern. Okay, so you do that first. The difference between create matcher and create single matcher is that when you run the single matcher function, it stops once there's a match. So like the idea is you're thinking, okay, it should only be able to match one of the possible cases. Create matcher will allow there to be multiple matches in case you want multiple things to be done to the thing. And then match object and match array, we'll see later on, is you can apply that, you can use that pattern. Instead of having to create your own sort of iterating logic, you can just say, hey, I want to run every key value in this object against this pattern matcher. Or I can say, hey, I want to match every element against this array, against this pattern matcher, and this will just make that simpler. So let's just show you an example. Let's pretend that I have a string. Okay, so I'll say const stir equals I am cheese. Okay, and then we're going to create a matcher. So I'll say const matcher. So this is our matching function, equals create matcher. And then basically, there's only one argument that this takes, which is an array of arrays. Now, each array takes in a case, and then a function to run if that case is matched. Okay, and basically the case is, so instead of it saying, okay, does this equal this, the way it works is you're saying, does this expression evaluate the true? So essentially the value you're going to pass in is always expressed as v. Okay, so literally just treat v as the thing you're matching, and you can just write any expression you want. So I want to say, like, we're going to pretend that v is a string. Okay, and I think it's like v dot test. Or actually, I think as you do the, let me just double check the documentation I was reading on Regex. Regex. Okay, I was looking for test. Is that on? Yeah, that's on the Regex itself. Okay, test. So in that case, what I want to do is create a regex. Okay, so we'll do a regex expression in the string, which I want to see, is there the letter I, oops, is there the letter I with a space after it? Okay, and that should be like the regex expression, and then I want to say like dot test, and then that's going to return true or false, and that checks to see if that is true or false. We'll try that in a second. And then it runs this function, and the function is going to receive the value being tested. So I can just say v for value, and we'll just say, you know, console.log. I can do as much as I want in the function. There is an uppercase I. Okay, now I get this function, and then what I can do is I can run the matcher and pass in the value I want to match it against. Okay, and again, I can create as many of these as I want, but we'll do that in a second. So now let me run index.js. Okay, unexpected token, boolean test. Did I use the wrong types of slashes? That's right. I guess when you're evaluating, that doesn't work as well. So let's do it this way. Go back up here, create a new regex expression. Okay. So we'll say new regex. And let's see if that likes that better. Regex is not defined. Oops, did I spell that wrong? Oh, it's regex. Regex. Okay. And that just might be because I Okay, to keep it more simpler, again, my regex skills aren't the best. So let's just do a normal includes. Okay, so we'll say v dot includes the letter I. Okay. And there I see. So this expression is true, and then it runs this function. And I can have multiple of these. So I can just be like, okay, I also want to check if I were to split v, actually we can just do length. Is the string's length greater than 5? Okay, and if that's true, then run this function. Okay, console.log length greater than 5. Okay, so again, the idea is that I can identify things. So I could sit there and put like different checks against like an array or a string, and then, you know, make different types of alterations depending on whether certain things are true. That may be completely unrelated. So the length is greater than 5. So in that case, if I wanted to like lowercase things, I could check to see if there's any uppercase letters, lowercase them, but then if I want to make sure there's only 5 letters, I can also check, hey, is the length of this string over 5, and then reduce the 5. I can just create all these sort of lists of checks that I want to do, and it'll just run through them and do what I want it to do. Okay, which is pretty cool. So again, you just treat v as whatever you're passing in, and you write expressions that would be successfully evaluated. Okay, all the normal JavaScript rules apply. Okay, so you just got to make sure that you use JavaScript and capture and don't write stuff that would error normally. Okay, and then again, the way I'm using eval under the hood there's no actually interpolation or injection into the string, so it's perfectly safe. There's no way to, in a sense. Okay. I am cheese matcher, great matcher, create matcher, and yeah. Also, there's a return value. So when you run matcher, it actually makes an array of all the return values. So if those functions return a value, you can capture it. So if instead this function just returned these strings instead of console logging them. Okay, I don't even need the word return. So now it's returning these strings. Actually, I don't even need the parentheses. There we go. Then what I could do is I could save it in a variable called result, and then if we console.log result, okay, so there's an uppercase. And so again, it allows me to do like sort of a chain of checks, and then again, I can take advantage that since this is not just a set of curly brackets like an if statement, it's an actual function, I can take advantage of all the benefits of function. I can destructure the parameters if I know what's going to be. So if I know it's going to be an array of 2, I can then destructure things, or destructure certain properties if I know it's going to be certain types of objects, because you can check like the object prototype. So you can sit there and if you know you have a bunch of different objects of different types, and there's a similar transformation but slightly different depending on which prototype it has, you can just do a pattern matcher saying, okay, if it's this prototype, here's the transformation. If this is and then you just run it against that matcher. Okay, cool. And now the only difference is if I say create single matcher, okay, then that does only matches like the first one. Okay, so there's an uppercase I. Once it hit a match, it stops. Okay, so you notice at that time I only had 1 in the array. Okay, now we created a matcher. Now let's say I had an array of strings. Okay, so let's just say we'll create result 2, and then we're going to use the same matcher, but I want to match it against several different strings. What I can do is I can basically say, here's an array of strings. I am, okay, eat cheese, bread, okay. And then I say, okay, hey, I want to take this array and match it against this matcher. What it's going to do, it's going to loop, pass this to the matcher, then pass this to the matcher, and then actually returns you an array of all the return values. So again, if I console.log this, result 2, and you can see here, again, I am should pass the, is going to be greater than, is it greater than 5? 1, 2, 3, 4. Oh no, that's the first one. And then the second one just gave us back an empty array. Because is there an uppercase I? Yep, there is an uppercase I, so why didn't that match? Result 2. Did I put the arguments in the wrong order? I might have put the arguments in the wrong order. Let me go read the docs of my own library. Let's see here. Match array. Oh yeah, you put the array first. Match. Wait, did I put the right name function? Yeah, I didn't put the right name of the function. Match array. That's the function. So you pass in the array first and then the matcher. And there we go. So you see, like now, again, the very first item, I am, there's an uppercase I, but it's not more than 5 letters. The second item is over 5 letters, and then the third item is not. So you can use this in all sorts of different ways, but allows you just to do a lot more complex testing of a value. So you can just set up all these different checks, aka patterns you want to match against, and then take the action you want to take in response in a very easy to use syntax. It's just basically like one line, like array expressions in a sense. Okay, again, expression and function, expression and function. Okay, when you write it out, it's not so bad. Yeah. And it allows you to take advantage of a lot of things. Basically, anything is available to you within this expression. It just needs to be able to be reduced down to a Boolean, because it will get coerced into a Boolean. So if you do something that's not really coercible into a Boolean, you'll get weird results. But bottom line is like you can check, hey, is the array length 5? Is the array length 2? Is the object's prototype this? Okay. Is the array have a length of this, but the second value is worth this? Literally any Boolean expression you can imagine, you can put here, same way like an if statement, but again, you're not writing all as many curly brackets, and you have a little bit more flexibility. So, and then the cool thing is that you can pile them all up into one function, and then you can just use that function. And then if you want to use that function as a iterator against an array or an object, let's show an example of that. So let's say we have this object create. We'll just say const obj equals name Alex Merced and age 35. Okay, now I want to create a matcher. Now the thing, if you're creating a matcher for an object and V is going to be the object, okay, the thing you have to kind of keep in mind is that when we use this match object function, it's going to pass in the entries. Okay, so if you're not familiar with what that means, is that there's a function on objects called entries. And what it does, it returns an array of arrays, where each array is the key, then the value. So essentially you're getting a bunch of arrays as the thing you're matching against. So you have to kind of imagine V as an array of the key and the value. Okay, so the key being index 0, the value being index 1. Okay, so again, I'm going to create my patterns. Okay, and let me finish this. Const matcher equals create matcher. So let's say I want to check, does V0, the key, okay, equal name. Okay, if the key is name, okay, then that's the deal. Okay, and then in that case, I will destructure. Again, I'm receiving an array, so I could just do something like this if I just really care about the value, and just say, hey, I want the value, and do something like that, and just say, something like return the name is value. Okay, and you see I recognize it's a key through the expression. That's the pattern I'm matching. So again, I only want to do this function if this is the name. Okay. And then I want to do that. And then I can do the same thing for like the email or the age. So we'll say V0 is age. And we'll just say the age is just as an example. Okay. And then I can say const result equals match object. Then I pass in the object, which is obj. Then I pass in the matcher. And then let's console log the result. Okay. I see the name is Alex Merced, the age is 35. Okay, so if there's some sort of like, then again, you can kind of do this with like object.keys or using like an in loop, but you can do more complicated questions. You can say if it's age and something else is true, if it's number, so you can create as many different patterns you want to check against as you want. That can be as involved as you want. You can be like, okay, well, you know, if the key is age, but the, you know, then let's, for example, if we say if v and then and, okay, the v's 1, that would be the value. So if the value of name dot includes, again, an uppercase A, then we check for something else. Okay, then we'll say, okay, then we do that, and if not, I won't do that. So for example, if I were to create a second object, so let's just make it, and this one is not Alex Merced, we'll just say this is Joe. Okay. Okay. So then what I do is I'm going to say for, let's just say match object matcher, and then we'll do another one for second object, result to match object to, okay, and then we'll just also console log result to. Did I call it object again? Oh yeah, I didn't call it object 2. Okay. And then you see, if, like for the first person, okay, age is 35. Ah yeah, so see here, this is the results. Actually, here, let me constant this so it's just not murky the waters. Okay, and now let's think about that object 2. Joe. Run this function value and v1. Oh, I see it because I didn't do it as a array. So that was right. That was right. My brain just, it's whatever. Okay, so you see the first time we ran it against the first object, both of them were true. Because again, this is the name and there's an uppercase A in it. While this one does not. So you can do sort of complex like checks pretty easily on several objects. I could just like loop through an array of objects and just keep running this match object thing to run all sorts of different checks on it. Pretty much easier than, you know, creating some, you know, large chain of if statements or some really contrived switch statement. Now, structural pattern matching hopefully will be a feature eventually in JavaScript, not in the way that I did it. Like, let's see here, structural pattern matching. Leave site, no, that's just going to give me in general. I want to get it in JavaScript. Okay, so you see there is a proposal for structural pattern matching. Okay, but this is only stage 1. It's currently stage 1. And if I remember correctly, like stage 1 are things that they're looking for proposals for, but they're not necessarily like getting ready yet. Like, let me just see, like TC39, there's like a description of what the different little stages mean. Proposal, proposals. Okay, so see there's stage 1, stage 0, stage, okay, and then there's stage 3 proposals. So stage 3 proposals are the ones that are like, they're about to get added. Okay, so like these are good to go. Okay, stage 2 are almost there. There's still like I see, I think there's a good explanation somewhere here. Okay, proposals that follow the process documents list. There's only stage 2 proposals and higher that have not yet been withdrawn, rejected, or become finished. Stage 2 indicates that the committee expects these features to be developed and eventually included in the standard. So that means stage 3 and stage 2, that means they're eventually going to be in the language. So you can look here and be like, okay, these things are coming down the road. Pipeline operator, that's actually pretty exciting. Okay. But stage 1, stage 0 means like, what's stage 0 mean? Stage 0 proposals are either planned to be presented, so they haven't been presented yet, okay, and have been presented to the committee but not rejected definitively, but have not yet achieved any criteria to get to stage 1. And then stage 1, okay, represent problems that the committee is interested in spending time exploring solutions to. Proposals follow this process document. Okay, so then you see you have here, these are stage 1, but again, they haven't gotten to stage 2 yet, which means you're probably years and years off before these things are going to be in JavaScript. Okay, but good to follow. And then here's like finished proposals. Okay, finished proposals that have reached stage 4 and are included in the latest drafts of the specification. Okay, so you can see here like when it was published in the specification. So we want to look for like the ones that are coming out for 2021. Okay, oh look, for next year we got the class fields we kind of already have. Match indices, that's kind of cool. Top level await, yes. Okay, ergonomic brand checks for private fields. .at, oh yeah, this is kind of cool. I did a video on this before. Accessible property class static block. Let's see, let's make sure this is what I remember it being. Method for the built-in indexables. A method to all basic indexable classes, array string typed arrays. Okay, and the idea is, okay, see prototype, define property value at. No, I just want to see an example of, okay, I remember I did a video on this somewhere. So you can go look up like .at, and I showed you how you can just basically create your own version of it in the meantime if you want to play with it. Cool, but yeah, so the point is like structural pattern matching isn't coming anytime soon. Okay, so try out my library, tell me what you think, leave a comment, have some fun with it, have a great day and enjoy.